Okay, well done on making it to the end of the labs. This week you'll be looking at the photoelectric effect. So hopefully you'll be learning to understand the concept of the photoelectric effect and how to use that to experimentally verify Planck's constant and also the work function of specific materials. So you'll be doing that by, in part one, measuring the stopping energy as a function of different wavelengths to determine what Planck's constant is and the work function. So this is the irrelevant equation, and you can see if you plot the stopping energy versus the inverse of wavelength, then you will get a linear relationship which shows you Planck's constant and the work function through your slope and y-intercept. And in the second part of the experiment, you'll be measuring the stopping energy versus changes in the intensity of light for a given wavelength. Okay, so for the photoelectric effect, the setup's fairly simple. You just need to make sure that you've got your power supply, which is connected to the back of your photoelectric effect box. So just connect it to the AC power and have it on 12 volts. Alright, so if you want a detailed schematic of this, you can look up in your book, but the basic components are you've got your nanoamps, so your ammeter reading here, your voltmeter reading here. You can adjust intensity, the wavelength that you're putting in, and change the backing voltage you're applying. And if you lift up here at the back, this is the LED source that's contributing to it, so just make sure that that's attached and secure. So when you're ready, you can turn your power supply on. And so for the first part, all you need to do is find the backing voltage which stops the photocurrent. So if we're on the blue wavelength and 100% intensity, we want to find the point at which you don't get any current reading at all, because that means that's the point where you finally applied enough voltage to repel the electrons away that are trying to jump across due to illuminating the cathode. So you move your course setting until you find it's close to 0, and then you can adjust it with this fine knob down the bottom. And when you know 0.1 is close enough, so that's good, and that tells you that you have to apply minus 0.893 volts to get the current to stop. Okay, for the next part of the experiment, you're just looking at how it varies with intensity. So this is the intensity knob down the bottom, and so you can just adjust this and then find out what the stopping voltage is for each of those. Alright, so a lot of the problems that stem from this lab are students not quite understanding the concepts behind the photoelectric effect. So I'll just briefly go through some of these in a bit more detail. So the kinetic energy of your electron in a photocurrent, the Ke, is equal to the energy of the photon supplied minus the amount of energy required to excite an electron into a conductive state, which is given by the work function W. So now that we have this, we can find the maximum kinetic energy of electrons in the photocurrent by increasingly changing the voltage until there's finally no more current, and that's what our QV stopping is. So we can substitute that into this equation, and we also know that the energy of a photon is just equal to Planck's constant times the frequency of that photon. So if we substitute these both back into the equation, then we get what we started with. So one thing to notice here is, where does the intensity of light come into, and does it play a role? So that's just something important to think about to help you answering questions in the lab. So another common error is people getting their units mixed up. So if you're using SI units the whole way through, then your result in energy should be in joules. So just try and remember one of these unit conversions. So you just have to remember the factor of 1.6 times 10 to the minus 19 joules, and you can figure out what the result is in either electron volts or joules. So just make sure you understand this conversion before you go into the lab if you struggle with this sort of thing. Secondly, be wary of units on your graph. You might have it minus 10 to the minus 19 joules attached rather than just 1 joule to a certain axis. So make sure if you're calculating slope or y-intercept, you take into account all of the units and significant figures attached with that axis. Also, be wary because your graph doesn't always have 0, 0 at the origin, so when you're calculating slope and y-intercept, you should just double check what your origin actually starts at. So that's it, just some reminders to check your lab marks for everything on Moodle and also to get your calculator approved before exams. Other than that, I hope you enjoyed the labs and enjoy this last one, and good luck.